here. We're on time. Might as well kick things off. Um, so yeah, welcome to the second and I guess final office hours of the hackathon. Um, Kind of reaching the end of the hackathon period here. So submission deadline is on Monday. I think there's quite a few people that have been working and will be submitting this week. So this is a great time to kind of ask some more questions and get some additional detail to wrap up those projects. There will also be one additional video that Joao and I are going to put on, I think releasing on Thursday. It's going to be most likely at this point, which is just going to be kind of, final details about submitting the project, suggestions for kind of how to make your project stand out and what the judges might be looking for, just in terms of the description and, just the details that are going to be important for that judging process. So sounds like there's a lot of good projects in the works. And it's just a matter of presenting those projects and making sure that the judges can see everything that you're doing and why it's important. So look out for that either Wednesday or Thursday, but probably looking like Thursday at this point. So to start, I don't know, let's say we've got one person on the call here. Feel free to throw out any questions if you got something you want to start with. Otherwise, we can jump over and find something in Discord. I think last time we were able to find some good content and lots of good questions, both from Discord and the group. So I saw an interesting question that maybe we can just get started with in the chat, or sorry, in Discord this morning. Let me share screen so that we can see that. So from this user here, they had some questions just sort of about building the project, but then this one is actually a pretty interesting one. What they want to do is have sort of currency transactions that also have a custom fee. So there's two ways to do this currently. One you can do right now. One has been in progress that will actually probably come out of the next release. So you're not going to be able to make use of it for this event, but there are some workarounds also. So the first use case would be you want to create a custom fee for your token. So by default, all token transactions within Metagraph have zero required fee. That mirrors how DAG operates, is that there's no fee by default. You can add a small fee to do things like increased priority, or there's certain situations where fee is required for a security purpose. There's one fee around wallets with very low balances can't have essentially a rate limit unless they provide a fee. So those exist, but there is a way within the Metagraph framework to override the fee within your Metagraph. So let's just quickly look at the example of that. So custom transaction validation examples where we'd want to look for that. So this is a really simple Metagraph. The idea is just to show you exactly how you implement this particular feature. If we jump into our L1, is actually the currency L1 versus the data L1. And there's this function available to you called transaction validator. And so the very simple way to handle this is to, if a transaction has what we're dealing with here would be a currency transaction. So this isn't a custom data transaction that's coming through your data endpoint. This would be a token transaction coming from a wallet. You're able to create a sort of any logic you want within this function to reject that transaction if it's not what you consider valid. And so in this case, we're requiring at least a fee of 10 datum, so very low fee. Anything above that is valid. And then the other here is that we're showing that if you want to introduce a fee at a certain point in history, so you could say, okay, this fee only goes into effect at ordinal, in this case 10, it could be ordinal 1,000, 1 million. So you could kind of implement that fee once the Metagraph is already running. That's kind of what's being shown here. So this is a really simple way to implement a fee on a token. Before I jump into the data portion of this, I guess maybe Marcus or James, you guys have any thoughts on that?
I think you covered everything. So like Alex is showing, he mentioned it that this is the transaction currency transaction. So just remember that everything that is on L1 module that Alex is showing on right now is related to the currency layer. The data layer, it will be on the data one module. And on this example, we don't have this data one because like we mentioned previously, we can have metagraphs that will not operate on the data layer, just simple currency metagraphs. That's the case that Alex is showing right now.
So to address this question more directly, I think this is probably asking more, hey, what if I want to send a custom data update and have a particular fee structure that's required for that? So we have a set of features that is in the works. It was actually briefly on testnet, but got pulled back because there's some more work that needs to be done on it. So it's not going to be available for us here. But it's the kind of overall concept is the idea of a fee transaction. So it's a transaction that you could submit along with a data update that contains a fee. It becomes kind of this self-contained signed transaction that can then move through state otherwise. But that's going to be eventually the way that it's suggested to implement fees associated with data updates. There's going to be Stargazer wallet support for that. It's gonna work pretty well. In the short term, so for this, especially for this hackathon, that's not going to be available. The primary strategy that would work well for this would be to, I guess, just send two transactions. So the first would be send a currency transaction or token transaction to an address, and then within your data update, have a reference to that transaction hash, and then the Metagraph can validate that, yes, that transaction was received, it's in state, it is of the correct amount, and can accept or reject that data update based on that previous transaction. And so that would allow you to use current wallet support to charge a fee and then either accept or reject the update based on the presence of that fee. So that'd be the suggested way to do it now.
I think what you just outlined, Alex, was how I can like gate writing a data update via the data L1 to the Metagraph with this, like by requiring the currency transaction first, right? But the way I read this is they also what he's asking is if he can gate reading data from the Metagraph with this with like by requiring a certain currency transaction. But I think the process is almost the same, that I could in my GET request, like in general, you have to be careful because GET request, it tends to be easy to just read data. And if I can deserialize the currency snapshot, then all the data is actually just public. So there has to be a little more thought into how to actually gate reading. But if you were to put encryptors on your, like an encryption step before you wrote data to the global, so that way only the Metagraph is allowed, like has the key that would allow it to decrypt data and then read it. And then in my GET request and my GET HTTP method, I would require a transaction very similar to what you said before, that would have to have a hash that would look to see, was this of a certain value based on the type of whatever data is being requested. And if that transaction did exist in state, then it can return that data to the user.
Maybe something on the calculated state. I can, like, it's just a concept, but maybe use the roles concept where we have different types of data that if the user have like a specific layer, a specific role he can access. So let's say that I have private information and I need to have the role of admin to take a look. So probably you can receive a data update like promoting that user to be an admin. And if this user is promoted to be an admin, you put on the state that this user is allowed to take a look at this part of the state and then maybe get that hash or something like that, or by address. And then on your get custom route, you can validate like by a hash or by a bearer token or something like that, as you prefer, because it's completely customizable, but maybe add on the calculated state that concept of roles that users with determined role can access one data, user with not with that role cannot access, or a different role can access other part of the state. So you can do the state customizable the way that you prefer.
Yeah, you could
Yeah,
essentially implement a standard subscription model, right? Like where you
Yeah.
you pay for a subscription that changes your account in some way, whether that's a role or creating a particular token. And then when the user submits their GET request, that would include a token in the header. And so you have full access to the headers within your GET endpoints. You could, get or you could accept or reject at that point. So those would all be options of how to handle that.
Yeah, just so I'm the one that asked the question in there.
Hey.
Just to clarify, like the use case basically is that on one side, I'm having consumers provide health data, but they can kind of control the privacy of what they want to provide. And then on the other side, I have AI researchers who want to train on data and are willing to pay for more private data because that can enrich their models. And so the consumers basically have an option. If they want to earn more, they can give away more of their privacy because the AI researchers are leaving it. That's the kind of flow that I'm kind of trying to build. So on one side, I had the data ingestion piece from the providers working where it's like stored on chain and all that. And then now I'm trying to figure out from implementing it from the researcher side. And the point of this is that it's as simple as like when they request a data set, they can I'll just give them some kind of API endpoint and then they'll just request the name of the privacy level of a data set for the hackathon. So it'll just be like privacy level low. And they don't need to query. I basically have to get all the data that meets that condition and then give it to them. But there's a price that they need to pay to access that.
Okay.
And so that's the thing I'm trying to implement. So maybe you guys already covered that in the things that you just brought up, but I don't know if that helps simplify.
When you send an update, so let's say that you are promoting a user pay you that he wants to have access to the medium level, as an example. And then once you receive the payment, you can send the transaction like change role to this medium for that address that you are trying to aim. And then when you send that update, by default, we return to you a hash of your data update. So maybe you can use that hash, like you can put that hash in like a allowed hash or something like that. And then if user provide that hash as a header or something like that on the custom roads API, he can have access to that information, like a pretty basic out system that you can use the own return hash from the update to access the data. Of course, that you can implement more elaborate, like when you send an update, and then you can have another update type that you generate the authorization using maybe OAuth 1, OAuth 2 bearer. You can provide any authorization that you want, but just a simple example, you can, like I've told, send the change role request, get the response hash, add that hash on the state, has allowed hashes, and then the end user can use this hash as header. And then on the custom rows, you can compare, like, if I provide that information, that key, if yes, I have access to that state part, and then I can just return to the user.
So for the roles, like I said, are there any examples where that role stuff came into play? I don't know if I saw it in the basic.
No, we
like,
don't have
do
actually.
ones that are...
But like it's basically
Okay.
how you define your calculated state. So you probably have a map with the key will be the roles, and inside
Gotcha.
it will be the content of the state of that role or something like that.
Yeah, I think
Got it. Okay.
there's other kind of important topics that touches on also around privacy of the data. So like when you have users submitting data, if you put that data directly into your on-chain state, that's essentially public data that
Mhm.
could be viewable, since that on-chain state will go directly to the hypergraph. It'll be visible there if they can decrypt or decode the snapshot. So you can kind of think about ways that you might want to handle that. One would be encrypting the snapshot so that only the metagraph can decrypt it. So you can do that through one of the lifecycle methods. Maybe someone can help me on which exact one. So that would be one option. The other is to kind of maintain an external data store that saves just the notarization on chain. So we see that sometimes in like Door is doing something similar to that, where the actual content of the data is not on chain, but just the notarization of the data, so that we can prove that if you provide the full data set, that this was exactly what was put on chain, without revealing any of the content of it. Good.
Yeah, I saw your video for the door one, which is exactly what kind of helped me here. So the way it seems to work there is that these devices are sending data updates during the validation phase, and what you're storing on chain, you're actually hashing it and then storing the hash there. And then is the idea that Door, the organization, is then just having a separate database that just maps hash to underlying data.
Yes.
And so if anyone
Yes,
wants
the-
to query,
Yes, the concept here is we receive the sensitive information from the devices, and then right at the beginning, on the signed data entity decoder lifecycle function, we receive that raw binary format and convert into a CBOR format on Door, and then with that CBOR we have the sensitive event. So we made a post to the Door API, store that data there, get the hash of that data back, and then persist on chain only the hash. So on snapshots we will have the hash. And if we want to compare with database, we can get that hash and fetch on the private database to see the real information there. So that's how we nest everything on Door.
gotcha. Okay, so it's not that they're first storing the device data on their database, then sending it to you, and then there's a hash created that's put on chain. It's the opposite. So device goes directly into the
Metagraph.
decoder function that you said, and then you're making the post request to their database.
Yeah, like we are receiving the request directly from the hardware devices. We don't have middlewares like APIs and then the API sends to us. We receive directly from the devices, and then we process that data, send to the API, and get the response back. So we are the first thing that receive requests from devices.
Got it. And so once it's saved there, so let's say I use the same format, and then on the other side, when the AI, when they want to train on the data, they request it, they would then, I can find all the hashes based on the privacy level of what they need, because it's on chain. And then my application business logic would have to basically, once it gets all those hashes, go and get all the data from my database that's kind of off chain, and then provide that back to the researcher. Yeah.
Yeah, exactly. So in that case, like that external service is really what's gating visibility and access. So since there's so much customization of this stuff, you have to really think about, like, okay, for my use case, is my concern that I want everything public and on chain so no one can mess with it? Then maybe something like an external centralized service that holds the data would be a concern, right? But, oh, that's not going to work because that service could go away or could decide to not give the data, and that's a problem. Or is like the concern more about the provenance of the data, in that, like, we want to be able to track, like in Door's case, we want to be able to track this data was collected on exactly this device. It was collected at this time because it's going to be on chain at exactly that ordinal that maps to a time. But there is still this third party in the mix, and so that works for Door's case. But for some cases it wouldn't. So you really have to kind of think about that. Which parts of that are for your case.
Yeah, I think mine might be similar. It's the devices. So let's say it's kind of integrates with your Apple Health device or something like that, and it's just sending updates or every day for a single person. So I would have to still track which device or which person effectively by their device is sending the update. And then I have a time series of that update. So when the trainer, if the AI researcher needs time series data, they kind of have that. And so it sounds like the same thing. I don't want to put that on chain, but it sounds like it's like each of these devices be analogous to like a person sending a one piece of health data. Okay, yeah, that makes sense. So again, just to go. Oh yeah, go ahead. Sorry, James.
So one thing I want to point out that since it is health data, it's like pretty sensitive, right? So if that payload, when they first go to like send the data update that has all their health information, and all the transaction does is sign it, and signing is just off the, like just creating a string that says like this payload, it was signed by this person. It's just like an identifier thing. It doesn't do anything to obfuscate the data. So that first step from client to Metagraph, that like data update, even if the Metagraph hashes it and stores it in the calculated state, which is what we're talking about here, and then puts that hash on chain, and then you have the researcher come in and they can query that calculated state and get back the data. If they were to scan the entire chain of previous updates that created that state, they'd be able to get those payloads. So if you want an end-to-end encrypted solution, you'd need something where like the Metagraph has a public-private key pair, and the user encrypts their payload with a public key that when they send it over the wire and the Metagraph gets it, the Metagraph could decrypt it using a private key specific to the Metagraph, be able to read the data it needs, and then re-encrypt it and put the data update on the chain. And maybe you get rid of it as well if you encrypt the entire snapshot. But I just want to point out that there's also that first step of the data update. That payload may not be encrypted the whole time. And so maybe that should be some thought around there, not just the reading from the calculated state.
You were saying that the node should self-sign the update that's received at this case. Like it will receive the raw update from the client and then will process and then sign the update. So the node will self-sign the update before joining the Metagraph.
Not that it's self-signed, just to have that like first payload from the user be encrypted in a way that the Metagraph knows how to decrypt, is all I'm saying, is all I'm trying to get at. Because the currency snapshots that are stored, we store the list of data updates, right? So even if the state doesn't have the like complete map, if I can get the complete list of data updates over the entire history, then I can reconstruct that on-chain or calculated state, right?
Yeah, but we store on the snapshot the list of updates that we output on the signed entity data decoder lifecycle function. So we can receive this update the way that he is trying to provide. It's just provide has output of this function, hiding the sensitive information like we have on Door. We can receive the complete update with the sensitive information. We don't need to decode and encode if we want to. We just need to make sure that the output of this function will not contain the sensitive information, because this output will be stored on the snapshot.
So how does Door? Well, I guess for James, like for the Door case is similar where they're trying to hide. They don't want.
Yeah.
How do they solve that? That's then someone could just recreate the thing, or do they not care as much because it's devices, or?
Maybe I'm just not familiar enough with the steps that Marcus has taken in Door. But if there's that step of being able to pull out the sensitive data, or like pull out the data in the signed data entity encoder, then what I'm talking about won't happen. And it's just a matter of the only unprotected step is when the client first sends the data. And as long as they do that over a secure tunnel, then it'd probably be okay. And so I think I just may have to familiarize myself with what Marcus
main, Alex. Yeah.
Sorry, data on main.
No. It's shared data, main, decoders.
Okay, cool. Yeah, because the way the Door handles it is sort of the way that Marcus was describing, where the full data is sent unencrypted to the Metagraph, the signed data entity decoder, sorry, is the very first lifecycle event. And so you're able to use that lifecycle event to take the raw input, adjust it so that it can be parsed as a signed data update. And so in that process, you can remove any sensitive data if you want. So in this case, the data is coming in, sensitive data is sent off to Door. What you end up with is just the hash of what that data would include, and then it's parsed into this signed object. It's coming in a binary format, so totally unusual format compared to what the Metagraph is expecting. And so the main thing to think about if you're going to do that is that you still need a valid signature on the data. And so the Door hardware device is signing just the hash of the data that it's sending so that it can still be parsed here. So it's not signing the entire update, but just what will eventually be saved on chain so that that's able to be parsed. Or Marcus, maybe correct me if
Yeah, sure. Think about in this function has a schema agnostic. You don't have any schema yet. You are receiving a raw request, so you can provide anything that you want. So let's say that you define it that your data update type, just like Door, check-in update, we will have some specific fields. But at this point, you send a request that doesn't contain that field. You send just like a binary, like we are sending on Door. So we are working here as a proxy, as a middleware. We are receiving the transaction, interpreting, like decoding that binary, and then transforming the binary into what we want. So we are transforming the binary into ID and signature. This is required to sign the message, like Alex has mentioned it. We are getting also the hash because the device, the real device, is hashing the information and signing that hash. So we need to have at the final update the ID, the signature, and what we signed, because we need to compare if the signature matches. So it's exactly what's happening in Door. We have the ID, we have the signature, and we have the hash. So we signed that hash, and then later we will compare. This is my signature, and this is what I've signed. It's matching. If it's matching, it's a valid signature, and we move on with the updates. But if you take a look at the line 40, we have this decoded check-in with signature. This is where we had the sensitive information because we decoded this from CBOR, and then we are sending to the API, but we are not moving forward with that. You can see that on the decoded check-in with signature, we are not providing the events, the foot traffic events. We are just getting the hash, the signature, and the ID. We just send to the API what we want, and then we just remove it from the remaining flow of the Metagraph, the sensitive data. So my check-in update right now only contains what I want to expose, what I want to persist on the snapshot. So it's safe from this moment.
I guess the other to point out, sorry, just really quickly, is that we're actually enriching the data also. So we send this data to Door. It returns this response, which is going to include like the subscription status of that user, the rewards address, and then that information, the response is going on chain as well. So the sensitive data is sent and not put on chain, but the Door API's response.
Can you show the content of check-in update type, Alex? Is on shared data types. Yes, if you take a look right here, we have the public ID, the signature, the DTS, this is the timestamp from device, the hash that I've mentioned, and we have this API response. So it's an optional. Why is optional? Because sometimes the device isn't registered on the API yet, and we will not have back the response. So is device not found? So it's an optional field. If we don't have response, we will not move forward with that update. It's on the validation that you can take a look as well. But this Door API response is the enriched data that Alex just mentioned, like the reward address, if the device is installed. So all the things that we need to pay the rewards is coming from the API as a response. So when we have this, we are sure that we persisted the data on database and the data is safe. So we just return with the information that we need.
Got it. Okay. So yeah. So just to follow this bit, if you go back to the where is it? The decoder.
Yeah, here.
Like, so this is the very first entry point. So right now, so for me, probably simplified. I was thinking of just doing a JSON but I don't know how that would affect everything or if it does at all. But let's say it comes in whatever format, and then we decode it, and then you can get the fields from it the same way that you can get it within the build send update section you guys are doing right now. It sounds like, so right in line 40, if I look at the handle check door API, it's calling the save device check-in, which this is all in the door API.scala file.
Yeah.
And that, yes, this is all before we even have an update, right? This is like first you're sending it to door.
Yeah, this is where we have the request, but we haven't built the API yet. The update yet. We received the request, but the API isn't the update isn't built yet. So we will build the update to process with the lifecycle function. At this moment, we only have the request, and then we will build the update and proceed with the lifecycle of the Metagraph.
Yeah, so this is where
so
we get the raw request, and then, you know, decoding it here, updating it into a format that can be accepted. So
yeah, you can use
can
your
do a lot,
JSON.
yeah.
Like you can take a look that we are using media type text plain. We are using pure text, but we definitely have media types of JSON. We have the XML. We have a lot of media type that you can get that request and transform in what you need. So you can have custom decoders to get your raw JSON and convert to Scala class. So you have the options if you want to.
got it. Okay, so yeah, in the handle check-in door API, when you're doing the save as check-in, so you're hitting the post request with the fields that you've extracted, but the point of that request is to just get back based on the device and everything from the external database, from Door's database. What is their subscription status or whatever else information that you need to continue in terms of what downstream of actually putting it on chain or anything like that.
Yeah, so we're sending the sensitive data, which is the event, like the foot traffic event data from the device, to the door API. It's returning with subscription data, data that we need to send rewards to those users for providing the data, and then that's what ends up on chain.
Oh, okay. So they're not storing. So they're actually keeping track off chain of all the devices. And
Yes.
Yep.
okay, so that's not being that. So I guess in my case, it would be, because I was thinking that it would just be all the consumers who are putting in the data, the address that put it in, like it would just be all stored on chain somehow. And then on the reward, when it's time to do the rewards, it just kind of queries the calculated state at whatever interval, and it figures it out that way. But I get, this sounds
You definitely could. Door is a little more complicated because it's already like its own retail entity, its own business that exists. So there's a whole bunch of systems around like giving dashboard access, all these things that are already happening with Door that it needs that centralized database. But you definitely could create a system that, you know, registers the device with its reward address just through the Metagraph. That does kind of all those actions, subscription status, all those things could be just straight through the Metagraph. And then maybe the external API or external database is just for saving sensitive data. Or maybe you don't have one, but that would be an option.
Yeah.
So.
Yeah, I think that I'm trying to make it completely like autonomous and decentralized, so it's as much as possible. But like you said, because of the private data, it does make sense. I need to kind of keep it somewhere. But besides that, yeah, I'm just trying to make it as much as possible kind of the Metagraph handles itself. So is there, I know there's a, oh, go ahead. Sorry.
No, it's just an attention point before we move on. Like I've mentioned it, this is the entry point of the Metagraph. So we haven't made any validations yet. So if you are calling external part like we are doing with Door, you need to be sure that you are validating the data on the external point. And you also need to be sure that you are handling duplications, because when you send the data, you can, it's not 100% of the times, but maybe let's say that you have two operators that send the same information at two different nodes. If you are calling the external part, these two updates can be duplicated, and you need to handle this on the endpoint. I'm just saying that if you need to fetch external sources, on this point, in this entry point, you need to handle the applications and storage on your other part, because the update isn't built yet and we haven't validated the data yet. So it's the raw data that you are calling externally.
Yeah, that makes. So would it not make sense? Would it make sense? Would this work if the validation? Oh, I get it. You don't want it stored until it's validated, or at least externally as the first check that it's
Yeah.
even, and that happens all the logic for that. Yeah. But is there a way to just to do it without having to query somewhere else, or is the point? Maybe I'm mixing two things up. It sounds like when you're doing it before you do the validation and everything, it sounds like one reason for that is yes, they're going to handle logic on the door side, and then get you back info that can either reject it completely, like it's duplicated, so you don't even go on with it. But then also it's to store what if it does work, it's to store that private data in that API call. So it
Yeah.
kind of handles both. And then going forward, that private data is already stored before anything happens on the
Yes.
chain. Okay.
Yeah,
And then the hash.
you could say the only valid data that's stored externally is what ends up on chain. Right? So you may have
Yeah.
invalid data stored externally, but you could go through all of your valid hashes on chain, fetch the corresponding external data, and
Yes.
have your full validated data stored.
Got it. Okay. Yeah, that totally makes sense. Just for like different rewards ones I know there was an example with the rewards for one of the Metagraph examples. You think that's a good reference? That's structured differently than how Door does it, or?
The door is the most complex reward system that we have. Like Alex mentioned, we have some business there and some tokenomics. So we have different rewards from different bounty types. So if you take a look at the door, is a more complex example where we fetch from calculated state. Yes, the other examples also fetch, but on door we check balances if the user holds certain amount of door. We also check like if we have that balances in certain amount of days. So we have some more complex stuff there. So you can take a look at the door, of course, if you want some more complex business stuff. But other examples like Alpaca is complete and simple in Door, because Alpaca basically reads from the calculated state and pay at the correct epoch progress. So it's easier to understand than Door. But
Okay.
yeah, you can take a look at both.
Okay. Yeah, I'll look at that one too.
All right. We can definitely circle back to some of the stuff. I see there was a question in the chat here. So the question is, can the currency layer be divided into sublayers? For example, sublayer 1 sends a cryptocurrency to the transaction recipient or sender for goods services delivered. Sublayer 2 sends DAG to Constellation Network for providing the hypergraph. Sublayer 3 sends US dollars to the government in accordance with regulations. There's a lot there. I think in the standard case, no, you can't really, like, the currency layer is just, there's an L1 and then the L0. So maybe some of the logic that you're looking at here could be something that could fit into those two layers. Currently, the current kind of limitation is that a metagraph is only dealing in its own token, and so it's not easily able to send DAG or to collect. Well, could collect DAG, but it's not easily able to send DAG since it's really kind of its own independent chain that has no access to any special tools for DAG. So I'm not sure if that answers the question, but I guess the kind of high level answer would be, I would try to fit your logic into those two layers. It's going to be much easier to send tokens than anything else. US dollars, you'd have to do some sort of external integration to handle that.
It can be done wrongly and harder. Like if you have on the rewards function calling external APIs saying, hey, pay for me that address, that amount of data. But this will require you to have an external service that will run probably DAG4JS, and you have set up wallets, so it's a little complex. It's not the normal flow. You need to do by your own, but yeah.
Any other questions? Bruno, how's it going with you? I know you were working through some wallet stuff over the weekend.
Hey, yeah. Yeah, so basically I figured out some mistakes in the whole process. So the signatures generated by the YubiKey, they seem to be correct. Like as speaking of the curve, right? I am able to pipe in a SHA-512 hash into the YubiKey and sign that, and it returns a signature. And I got it working for for valid successful validation for the JavaScript libraries. But the YubiKey sometimes returns a like the S value of the signature, like the higher version of the two possible valid ones. So when I validated it through DAG4 key store, sometime, roughly half of the time it's like successful and the other half not. But if you set the, allow the higher S to be true, then it works all the time. Same with elliptic. So also another mistake I figured out is that Constellation Network, the DAG L1, the signature is not encoded as raw hex, like for like 232-byte values, but it's actually ASN1 encoded. So there's like a byte prefix, like sequence of numbers. Then there's the length of that number, and then only it shows the 32-byte integer. So I think I got the encoding, like I fixed encoding, but for some reason the network still rejects the transactions. And this is essentially where I'm left right now, where I might, I don't know, there's something Constellation specific which I might have overlooked. But I have a working setup where I can generate valid signatures. I mean, in the worst case, it just generates signatures until the S is lower than the valid essentially, and then send this to the network. But yeah, as far as I reverse engineer, the signature is ASN1 encoded, and the ID is just the hex, the raw hex of the public key bytes. But still gets rejected, and I don't know why.
Wait, so if it does generate the low S version, is it accepted by the network, or still it's always rejected there?
So it's rejected in both cases. I mean, if you want, I can quickly share my screen here. I have a working like demo, if that's cool. So we can go through a specific example. But I have to be allowed for this though to share my screen.
How do I do this? Okay, try again now.
All right, so this is the signing window. When you click, in the Stargaze extension, sign a transaction with the YubiKey wallet, then this window pops up. And when you click sign, essentially this sends all of the data to the local bridge and then calls GPG for some pre-validation, and then sends signals to the YubiKey as raw APDU commands. And in this case, I clicked the button twice. Like the first time it generated, like, let's go just through the step by step. First, the wallet prepares a transaction, right? It has an empty proofs array, sets the amount, destination, the parent. This is like the first transaction this wallet made, sets its data. This is then sent to the YubiKey bridge. It looks for a key with this fingerprint. It hashes the transaction hash already. This is down here is the transaction hash that just got generated. This is the SHA-512 hash UTF-8 encoded. And then it gets this. I don't know if this is correct. But as far as I can tell from the Stargazer code, the hex string of the transaction hash is taken as UTF-8 and then SHA-512 encoded. This is then sent through the pipeline to the YubiKey, where it is then directly loaded onto the key and a signature is returned. this then is already DER encoded. So it takes the raw 2 times 32 bytes and puts, like the sequence identifier, the length of the sequence, then the integer identifier, and 20 is the length of the integer, 20 in hex, so 32 bytes. Then comes the first R value, and then at some point in here, like the second S value or something. And this ASN signature is then added as a proof here in the signature, like to the transaction, with the ID being the hex encoded public key of the address. And this is also the same public key where the DAC, the from DAC address is generated. And then here, on the first time I clicked this button, look here, this was the signature verification that was piped into the key store, DAC4 key store. Verification was false because of the higher C. The second time I clicked on this, went through the whole process again. Down here, the DAC key store verification returned true. 50-50 chance basically. But even in the case where DAC key store said it's valid, the transaction post method still returns an invalid signature error. And yeah, like now I would need to debug the tessellation DAC1 layer to reverse engineer how the signature must be encoded, or whatever requirements needs to be met.
Thanks, Marcus. Yeah, I did not realize I was muted. One thing to debug would be to, try to, I guess I'm trying to think. So you don't have access to the private, like the raw private key, because it would be on the YubiKey. So we can't like pull that out and use that in DAG4.
I have. Actually, there's this specific curve that we're using. It's not possible to generate it directly on the key. So for the initial setup, you have to generate it on the host machine and then load it onto the key. So there's access to it.
Okay. Could you try to generate the same, like at least the encoding? Is that the first thing I would do would be like the encoded value, because it's kind of an unusual coded value. It seems like you touched on some of the parts of that, but it's like length encoded in a particular format. Could you verify that is the same?
Yes. So, I mean, initially I just sent the raw 64 hex string encoded signatures to the network. They got rejected. And just today I figured out when I look at the global snapshots, that all of the signatures are basically ASN encoded. And as far as I can tell here, so 30 indicates a sequence of bytes, 44 is the length of this, 02 indicates an integer, and 20 is the length. 20 means 32 bytes, and then 32 bytes an integer. So all of these signatures that I find on the on the network are ASN1 encoded. So maybe they are. I don't know.
Yeah, I mean, we could track down, not sure the easiest way to like have you do something using the code on the tessellation side to validate the transaction, because it's going to accept it from the transaction endpoint. It's going to then try to parse it as a signed class, and there's a lot of things that could be incorrect there that would then just throw a invalid signature error. So like if the structure was incorrect, if it's very incorrect, it would throw a different error. But if there's some things missing there about the encoding and how it's signed, those would also throw invalid signature errors. So we can try to look up some links to kind of help out with that process. But I mean, you might also try, because like one thing I noticed is that like that address has never sent a transaction before. So just at the point of debugging, you might try to send a transaction from that address. I don't know if there could be something wrong with the parent hash generation that should be correct, but just from eyeballing it looks correct. But you're saying this to the hypergraph, right? This isn't dealing with a Metagraph token. It's
I sent it to, I mean, the Stargazer wallet actually sends us to L1 load balancer mainnet. It's a DAG transaction.
Okay, yeah, that's correct.
So yeah, I mean, I have like a good testing setup with the known private keys around here. So I just like make this nice. And since tomorrow is my last day, I can actively work on my hackathon projects. I'll maybe look into this for another hour or so, but after that, I just continue work on this after the hackathon basically, because I think the most of the work is done. It's just some weird mistake somewhere, and running out of time basically.
Yeah, I would, I guess, encourage everyone, if you get part way with this, still submit these as hackathon projects, because we're looking at potential, what could this be, of course, the work that you've done, but a lot of this could be, hey, well, this could really become something really cool, worth a prize, worth maybe, one of the things that's being looked at is Stardust Collective has a whole grant program. So if you want to continue some of these projects, you might be eligible for a grant to continue that after the hackathon. So yeah, definitely submit what you've got. I think this is really cool, actually. It sort of turns into its own hardware wallet, or kind of roll your own hardware wallet. It's very interesting. So
yeah, Alex, and not even without the grants from Stardust, they have a pretty big community, which could probably be interested in some of those projects. So it's exactly as Alex said. Even if you haven't finished completely, if you're in the MVP or just have a approximation of what you're trying to accomplish, I think it's still worth it to submit it, definitely. And who knows, maybe that's even enough for some of the honorable mentions of on what you're trying to achieve, pretty specific prizes that you can accumulate. So it's always worth the shot, whatever your stage is.
So another question. So the snapshot maximum size is 500 kilobytes per snapshot, right? Does that mean the total on-chain state serialized, or does it mean all the updates for the snapshot that are new?
it means the total size of the snapshot. So that would include any data updates and currency updates that were processed as part of that snapshot. So it's like streaming size. Your on-chain, sorry, your calculated state could be many times bigger than that, since that's not sent over the network, but it would just be how big is that particular currency snapshot that you're sending.
So if the on-chain state gets bigger than these 500 kilobytes, then the Metagraph basically have to pay a fee, right?
No, so it's a hard limitation. You can't pay to get around the 500 kilobyte size limit, but it would be 500 kilobytes, up to 10 or 20 times a minute, right? So each individual snapshot can be no bigger than 500 kilobytes, but you pay for your entire on-chain state, which could be, that many snapshots over time. If that makes sense.
Wait, every snapshot,
Yeah.
the whole on-chain state gets serialized again, right?
No, so each snapshot contains only the changes to the previous snapshot. So it's what we call like an incremental snapshot. So it's like the incremental changes. You should maybe think of it like a git diff. Basically just what's changed. And then your calculated state is where that you would hold like all state. So like if you wanted to have, say, a wallet that has every transaction it's ever sent, maybe you have, not a great design, but just as an example, but maybe you have in your on-chain state an array that has, or a list that has every single transaction that a wallet is sent. Your on-chain state would just be the snapshot, and that would only contain a new transaction for that user when one is sent, but it would not each snapshot contain every transaction ever sent.
Yeah, but be sure to change on the combined function. Like if you receive empty updates, remember to clean the on-chain state, because the combined update with the combined function, we have the latest state and the last state. In the last state, we have the pair on-chain and off-chain. And if you add the same last on-chain state has a result, if you don't update, it will copy your last snapshot on-chain state. So you need to be sure that you will clean the on-chain state if you don't receive any updates.
So when you say clean, so
Set as
okay,
empty array, probably.
uh, but the actual data on chain state type, right? Like that should be basically, because so currently in my Metagraph, I users upload stuff to it, and like essentially they declare variables and upload models, and each model and each variable has an ID, and it
Yep.
stays in the on-chain state until that, I guess, forever. I don't have a remove method yet. Might that be a problem?
No,
Like it's a
like
set,
it's
essentially a set of strings which are hashes of the data.
no, like it's up to you. Like we just recommend, like Alex mentioned it, to clean, because if you just append stuff to your state, you'll reach a time that you exceed the 500 kilobytes. So that's the reason that we have the calculated state, is because, like, if you want to persist the state between all the calls, instead of putting on the on-chain, you let on calculated state, and then you just retrieve from there. But you can use uncalculated state, like, if not increase too much and exceed the 500 kilobytes, because if exceeds, your Metagraph will stop.
I think I'll figure out if I made something wrong there at some point.
Yeah, do we have an easy example that we can point to for combine? Maybe, let's see. Well, yeah, maybe take a look at some of the examples and see how it's doing, because I think all of the Metagraph examples should be doing that or handling that properly. But I guess, yeah, the other thing is that never mind. Take a look at the examples, and if you got questions, we're around, we can answer. But really, the calculated state is where you want to store that kind of overall information about on-chain state versus like what just happened in that snapshot. So.
All right. In principle, is it possible to use type parameters in the Metagraph types? It
Yes.
should come all down to normal types at the end of the day, right?
Yeah, you just have to. It makes defining the Cersei, or like your encoders and decoders for taking in updates, a little more complex, but it is possible to put type parameters in the updates.
All right. All right. Yeah, it's out of scope for the hackathon anyways. Just that's a question.
Yeah, it's we don't have an example of it yet, but I think I've had to do it recently. So I can try to look into incorporating into an example and make it public.
All right, guys. Well, yeah, I think we got through the hour there, and seems like some more good content. So appreciate all the questions, all the discussion. This is the last office hours for the hackathon. We're gonna try to be as active as possible on Discord, so please, any questions there, hopefully we'll get someone to answer. And then there still is the opportunity to book a one-on-one meeting through, the link should be in Discord and also in the most recent emails. So you can book with either Marcus or Chad for 30 minutes or an hour and discuss any issues you might have. So all that's available. And then Monday is the deadline for submission. So yeah, hope to see everybody's submissions. And like I said before, if they're not complete, definitely submit them anyways. Record a video explaining how it works and what might need to happen, and then just put in the write-up. All that detail. I think probably the biggest stumbling block for people is going to be not doing a write-up that explains things well. So the judges are only going to have really look at the video, the write-up, and then we'll try to run any code that comes in also. So, but yeah, thanks everybody for joining, and yeah, we'll see you later.